WHS challenges in the wind industry for executive management. Certain unique aspects of the wind industry potentially increase the health and safety risks of its workforce. First, the wind industry is a relatively new industry sector. New industries often suffer teething problems as they develop and refine their standards for training, equipment and so on. And it's during these initial phases that there are increased risks to the health and safety of staff. Second, hazards that exist in the wind industry are known to exist in other high-risk industries, risks such as falling from heights and manual handling risks. Third, like the mining industry, the wind industry recruits staff from other industries with the expectation that skills can be transferred, and if this is not possible, or where skills and knowledge are missing, training will suffice. But this type of recruitment is also compounded by the fact that these staff often have little or no experience working in wind farms, and often are unfamiliar with the unique WHS challenges that they'll face, including, for example, the relative isolation or remote locations in which they'll work. Fourth, data on the severity and frequency of accidents is difficult to obtain, and when available tends to be sketchy, making it difficult to determine the true level of risk and injury in the industry. This also keeps new recruits from knowing the real WHS challenges they'll encounter until they enter the workforce, that is. What's done at the executive management level to manage WHS risks? At the executive level, risks are managed through the choice of equipment, proactive checklists, and the development of policies and processes. Modern wind turbines are designed better and so meet international engineering design and manufacturing standards for the tower, blade and generator. But just using the safest equipment alone is not enough to safeguard health and safety of workers. Management need a comprehensive strategy that implements WHS regulations and standards proactively to manage the risks. This is needed during all phases of the wind farm project, whether installation, commissioning of the turbine into service, operations and routine maintenance stage, or the decommissioning of the wind farm. Best practice examples show that management who use equipment that meet strict industry standards and manage risks by using foundation design and commissioning checks, for example, that address potential failures such as from extreme events such as earthquake and extreme wind loadings, do a good job. But is management doing enough? What about what's on YouTube? There are notable examples of catastrophic wind turbine failures on YouTube. These videos show the potential ways by which turbines fail, particularly due to hazardous weather conditions, including excessive winds. Excessive winds place added stressors on the equipment and have been linked to various issues including tower collapse. This is rare and can be due to the improper installation of the tower fastening system, failure of one of the subsystems, or catastrophic failure. Tower strike is also rare and occurs when a blade hits the tower. Thankfully, all modern turbine control systems require complete shutdown during excessive wind speeds and thus significantly reduce the risk of the turbine or tower failing. Even so, there have been rare occasions when catastrophic failure of a wind turbine has occurred. Fires. Strong winds may be involved with fires as well as with faults in the power pack, but the risk of fire is very low for a number of reasons. The height of the towers above the ground, the minimal vegetation around the base of towers, high voltage connections are underground, access tracks act as fire breaks, lightning protection devices are installed on every wind turbine, and there's dedicated monitoring systems that detect temperature increases in turbines and that shut them down when a certain temperature is reached. In the past, it's been impossible to extinguish fires, which have been hazardous to those directly below the nacelle and to technicians inside the nacelle and tower. However, the height and remoteness of wind turbine generators has also meant that without fire suppression systems, the only thing to stop the fire has been the lack of anything to burn. Low-cost fire suppression systems, which release fire suppression gas at the hottest part of a fire and suppress a fire in seconds, are available and an increasingly important aspect of wind turbine safety design. Blade failure. This is also rare and may be due to fatigue, wear and tear, excessive vibration and collapse from external loads. However, wind farms tend to be designed and situated so that no buildings or populated areas are within a possible trajectory range of a blade, though the range varies with the size, shape, weight and speed of the rotor and the turbine height. So what are the real risks? It's been estimated that the risk of being hit by a turbine, turbine parts or ice fragments within a distance of 210 metres is 1 in 10 million, which is comparable to the chances of being hit by lightning. That's great news for the public, but technicians work within this range. Lightning. Fire may also be caused by lightning. Though wind turbines are hardly ever struck by lightning, the likelihood increases the taller the turbine is. Since it's impossible to completely eliminate the risks of a lightning strike, it's been more important to control its passage and conduct through the turbine and tower. This minimises the damage to the turbine and reduces the risk of fire. Significant investment has gone into protecting turbines from the effects of lightning, which in the past have caused fires requiring evacuation from the structure and rescue. Many modern turbines are now equipped with total lightning protection that moves the lightning in a controlled way from blade tip to the hub, through the nacelle, to the tower and finally to the ground. This is simple and extremely effective. In summary, experts say that international data shows there are very low risks associated with tower collapse, components falling from towers, and blade throws. Each year, there are more advances in wind turbine technology, more efficient and better designed towers and component technologies. Not only this, but the data indicates that the more that the technology improves, the more the risks to health and safety decline. What responsibility does management have in this ever-changing context? They must ensure that all strategies accurately reflect any changes and that different strategies complement each other.